Hey everyone, thanks for coming out today. My name is Andy Troutman. I'm a senior manager here in AWS. I mostly focus on our software deployment tools, Code Deploy being our publicly facing one. Today I'm going to talk about DevOps on AWS. Specifically, I'm going to talk about choosing the right deployment techniques for your application. I'm going to cover a few things. I'll keep returning to this slide and then we'll keep adding on to it. This talk, if I'm successful by the end, you will have a broad array of new terms and tools to go dig deeper into and some sense of what may or may not work for you. So we'll start by talking about how to reduce the blast radius of a bad change. So assuming that you release software that you probably didn't want to release, what can you do to make sure it doesn't impact all of your customers, the fewest number of customers possible? We'll talk about techniques to avoid impact altogether. So how do I actually release a piece of code and make sure that I'm as confident as I can be that everything will go as expected. And then we'll also talk about how to deal with data in the context of a software change. I think every time I give a talk on software deployment, this is the most commonly asked question afterwards. How do I deal with schema changes or data changes as part of my software release process? So I'll try and give you a couple tools for that as well. Throughout, I'm going to try and do some live demos, so that should be fun/terrifying. And hopefully everything will go well. I'll show you a bunch of different AWS tools and how you can leverage them to get your job done. So every time I do one of these talks, the piece of advice I always get is tell a good story. There's two ways to tell a good story. One is just to steal a good story and repurpose it, or to write a really good story. I'm not going to do the second one. I'm just going to steal one. So I'm going to steal a seminal 80s classic, Lethal Weapon. For those of you not familiar with Lethal Weapon, no problem. It's a buddy cop movie. You've got two protagonists. The first is is Murdoch, the grizzled veteran cop, and the other one is Riggs, his crazy sidekick, rookie cop. In our example, Murdoch is going to be the seasoned software engineer, and Riggs is going to be the new DevOps engineer. At the beginning of any good buddy cop movie, when they meet, there's always friction, so there's no love lost between our characters initially, and we have to figure out how they can work together and combine themselves to be better than their parts. So let's jump in. I'll start with how to reduce the blast radius. Punchline is slowly introduce changes to your customers. Don't go all broke and push out a change to everyone at the same time. So how do you do that? I'll start with this one by using Murdoch as our protagonist. So in Murdoch's world, every piece of software that's going out the door likely has a bug in it. It has a pretty big bug. It has a really big bug. He's always convinced that no matter what is getting released, it is probably bad. And so he spends a lot of his time thinking about how to prevent bad software from going out the door, and he puts a lot of rigor and process around the software release process. He knows that if he releases software on his first set of servers and it doesn't get caught, that it's going to propagate everywhere, and he's going to have many more problems. He also knows that he works for a large company, and the problem is even worse than he imagined because they distribute globally, right? So he's got problems all over the world if he doesn't catch it early. So what does he do? Compartmentalization is the name of the game, right? So how can we create tiny pieces that can fail independently of each other? How do we make sure that those pieces can be deployed to in absence of deploying to everything? So the first thing he's going to take advantage of is regional segmentation. He runs on AWS, so for those of you not familiar, AWS has this concept of regions. Regions are globally distributed stacks of our web services all over the world. They are network isolated from each other. They are fault isolated from each other. The intent is that if one region goes down, it shouldn't have any impact on any other region. So he gets this for free. As long as he's deploying and leveraging web services across regions, he's getting some light form of segmentation. That's, of course, not good enough for him. He'll also take advantage of availability zones. Zonal segmentation within any AWS region, you again have multiple isolated stacks that are intended to fail independently of each other. You can use those to distribute your compute logic, your web servers, or whatever it is you're running, your worker nodes, across the availability zones. And again, you get a little bit of additional segmentation. These are intended to also fail independently of each other. Of course, he's going to go further. Anytime he deploys, he wants to deploy in a phased manner or a rolling deployment, right? So this means deploy to a single host, see how it goes, perhaps test it. You may call this one box or canary testing. Make sure that it works as expected before you go and blast it to the rest of your customers in your fleet. So proceed with caution. In addition to server segmentation, we can talk about stack segmentation. Everyone probably already does stack segmentation, but if not, you should. In AWS and in Amazon, we typically have a 3 kind of stack architecture. We have the development environments where it's completely wild, wild west. Our developers push to it whenever they want. The code that goes there is in various states of testing. It can be for experimentation. Basically, everything in dev is highly untrusted. Once you have a set of changes that you think are ready to show to customers, that goes to a test stack or an integration stack. That's where testing is expected to have happened already. So you're writing tests that you're shipping along with your code. Your code is being tested there. Test stack looks a lot like your production stack. So for the most part, your test stack should be configured with the same permissions as production. It should be scaled, in most cases, similar to production. It should, as much as possible, mimic production. And then finally, production is exactly what it sounds like. It's when your customers are actually going to experience the new piece of code that you pushed out the door. It's available to everyone, and code that goes there, you should have the highest level of confidence that it actually is going to work. Right? So you'll see I've drawn little brick walls between these. The intention is that these are, again, completely isolated. Do not share credentials across your various stacks. Do not share permissions across stacks when you can avoid it. It always ends up biting you in some way or another. So that's Murdoch's view of the world. Everything has to be compartmentalized into tiny little pieces. Each one of those pieces has to have a report written about it in order to get it out the door. Let's switch and talk about Riggs's view of the world, how he believes software should go out the door. In Riggs's view of the world, he doesn't have time for that, right? He doesn't have time. He doesn't want to take a week to write a report about the change he's going to fix. While he doesn't disagree with the idea of compartmentalization, he doesn't think that's the emphasis. In Riggs's world, it's all about the code, right? And specifically, it's about complexity of the change, right? So in Riggs's world, reducing the complexity of any single change is the name of the game. To illustrate this a little bit, imagine you're shipping an update that's large. It could be a bunch of files across multiple web services, or just a lot of change even within a single web service. For every piece of change that you have, there's an opportunity for a bug. So with a big change, you have an opportunity for lots of bugs, right? So the bigger the change, the more risky it naturally is going to be. The more likely it is that you're going to get something wrong or miss an interaction or miss a test. And so this makes it very hard to ship these large changes. So in Riggs's world, we want to reduce the size of any change, and we want to ship more often, right? So ship smaller things more frequently. The nice thing about smaller changes is, even if they do end up having a bug, it's a lot easier to remediate that in the form of a rollback. When you have a really big change set across multiple services, or even within the same web service, when you encounter an error, you have a lot more space, search space, that you need to go through to figure out what exactly just happened. And so small changes make this a lot easier. If you're shipping things quickly and iteratively and frequently, it's very easy to say, it was working now, it wasn't working with this change, roll back that single one, right? So that's really where Riggs wants to spend his time. He's fine with compartmentalizing, but he really wants to focus on more of a continuous deployment model, right? So ship things quickly, ship things in small batches, avoid complexity of any particular change. So let's try and do a demo. Cool. So just as I said, I'll try and motivate this whole talk with some examples. So 2 tools that you can use to build out your release process. One is Code Pipelines. Code Pipelines is a tool we have here in AWS to visualize your release process and to automate it. For those of you not familiar with Code Pipelines, here's probably the simplest pipeline you could ever have. We have a source stage. and a little arrow that puts it into a beta stage that uses code deploy, right? So at a very simple, this is a simple visualization to show you that when I check in code, the first thing that happens is I pick it up and deploy it with code deploy. Now this is, as I said, probably the simplest pipeline you could possibly have. In the real world, you're going to have much more complicated cases. If we're going to follow Murdoch's advice and compartmentalize things to the nth degree, we're going to probably need some automation around building these pipelines and keeping them consistent. That's where CloudFormation comes in. CloudFormation is a template-driven service that stands up and configures infrastructure for you. It can also stand up and configure other AWS services, such as code pipelines. So what I'll do here is I'll just create a brand new stack using CloudFormation. Excuse me. So I'm just going to open up this JSON file, click Next. Something I won't lose in my list. Oops. This is just me acknowledging that I'm going to create some permissions along with this. Okay, so now we have the stack being created. This one I'm just creating the skeleton of the stack, so it should happen relatively quickly. So if I go over here to code pipeline and we give it a refresh, we should hopefully in a moment here see a new stack stood up. As you can see along the bottom here, you can watch the events flow by, so you can watch what step of the creation process CloudFormation is in. This one is going to create a bunch of roles. It's going to create some sample Lambda functions and upload them. It's going to do a bunch of things. All right, I'll give it 10 more seconds, and then I'll pull the Martha Stewart trick and show you a pre-baked one. Okay. Well, here's the exact same template, this DEV310. So I ran this earlier. Let me just click on that so that we're not watching CloudFormation do its thing. So here is a much more complicated stack. Here's just an example of automatically creating one. So as before, we have a source stage. This is where our code is coming from. Now we have a bunch of commit actions. Any of these boxes that are next to each other are happening in parallel. So you can have parallel actions within any pipeline stage. And then anything below them is a sequential action, right? So in this case, this is essentially building the code, running some static analysis, and if both of those things succeed, it will carry on to do unit testing. Then we head into that software release process that we've been talking about, right? So deploying code, running tests, waiting for manual approvals, deploying to a single AZ, running tests on that AZ, deploying to a production, the rest of the production AZ, deploying to the one box of the next AZ. I'm not going to keep going, but you can see, because this can get quite long, quite complicated. And the nice thing is that I didn't have to go build all of this by scratch. I could leverage CloudFormation. I write a template once, and then I can push it everywhere I want to. That way, I also have a configuration as code, right? So I have a template that I can check into my Git repository, and I can version control, and I can actually see anytime I want the definition of what my release process looks like. If I want to visually see it, I can go to pipelines and realize it there as well. Let's see if I, just because I'm personally curious. Okay, so stack did create. If I go back here, there we go. Same pipeline. Cool. Okay, so now that we've got our code pipeline set up, we've got something that can automate our release process. It's highly compartmentalized, so our seasoned veteran will feel comfortable with it. In any good buddy movie, at this point, they're starting to feel the love. They've beat the first bad guy. They've, arrested someone with a traffic ticket or whatever it is, right? So they're feeling good about themselves. It's time to go and take on the next boss. And it's also time to introduce our next character, which is the software dev manager, right? In the movie, this would be, of course, the commissioner or the chief of police. So one of the things that happens when you compartmentalize, if you do a really good job at it, is you end up with a very long pipeline, right? So if you take this to the nth degree and you have a one box for every AZ and you deploy every AZ and you do phase deployments in every AZ, you end up with something like this, right? It goes on and on and on. So you've traded off one form of complexity for another. The problem with an extremely long pipeline is that you can have lots of changes in different stages of the pipeline. And this can be just as confusing as releasing a big change one unit at a time. So what do? We need to look for some sort of balance here. Typically, what I would advise is try to figure out how to accelerate your release process as you go, right? So as I showed with code pipelines, I can run things in parallel. I would advise starting off slowly, just like we did before, deploy to a one box, maybe go one AZ at a time for your first piece of software. Once you see things getting through multiple stages of your release process and succeeding, then you can start to build confidence in that change and you can start to accelerate. So that's what you see here on the far top right is maybe then we can go to multiple canaries at the same time, right? So maybe release the code to multiple one boxes and see how that's going. If that's going well, we can continue with the production rollout in parallel. If you do this, it will shorten your pipeline, which means it will shorten the time it takes for any particular release to get out the door. And ultimately, that's a good thing. If you don't do this and you ship code very frequently, you end up with lots of little pieces kind of sprinkled across many, many different stages. And that can be quite bad. So just a lesson learned there. This also makes our dev manager happy because code is getting out the door and her schedule isn't getting interrupted. That's always good. All right, so we talked a little bit about how to compartmentalize. I've showed you a couple tools that I think can help you along the way. Let's talk about some techniques to avoid disaster in the first place. So anytime we talk about avoiding disaster, we're of course going to talk about testing. I'm not going to spend a lot of time here talking about unit testing. I'm hoping that everyone is bought in on the idea that you should test your code. If you're not bought in, one more person telling you to test your code isn't going to matter. So everyone should do upfront testing, unit integration testing. Instead, I want to talk about continuous testing. Some people call this synthetic traffic, or we call this continual canary testing here in AWS. The reason that I think that you want to do continuous testing is that I think you can catch a variety of bugs in your software by doing upfront testing, by doing unit testing, or end-to-end testing, or functional testing. All of these are good practices, and you should absolutely do them. But there are a lot of cases, especially when we're dealing with distributed web services, that upfront testing won't catch, specifically things that change outside of a software deployment. And for those things, we want to be able to catch them. We want to know about failures before our customers do. And if we're going to do that, we're going to need to drive synthetic traffic to our APIs or our services to make sure that they're continuously working. Some of the kinds of failures that I'm talking about, permissions problems, right? So if you change a permission, it can have an extremely big and wide impact on your services. That usually happens outside of the context of a software change. Dependencies, as we all move towards microservices and we have lots and lots of tiny pieces all talking to each other, a dependency that you don't directly own or pay attention to can fail and cause an impact on your service. That happens, again, outside of the context of your software deployment change. And then Byzantine errors, there's a ton of these, right? So the things you didn't test for, or the guy tripping over a power cord, or the hardware failure, or forgetting to rotate your logs and filling up the hard drive, right? There's lots of things that fail outside of an immediate software change that happen downstream that you potentially don't check or don't catch in your kind of formal testing. The other thing I'll call out is that one of the reasons we really want to drive synthetic traffic is because in a lot of cases, especially for control plane operations, so when humans are actually configuring things with your service, the call rates are usually relatively modest, right? Even for a large service, there are parts of your API footprint that are probably very rarely called. So just as a thought of experiment, if you want to be able to monitor things with 5-minute granularity, so you want to know roughly within 5 minutes that something is broken, There's this theory called the Nyquist rate. I guess it's not a theory, it's a rule. Nyquist rate in sampling theory basically says that if you want to know something at granularity X, you need to sample it twice as frequently, right? So in this case, if I want to know about a failure within 5 minutes, I really need to have a continuous heartbeat of API calls to it every 2.5 minutes. And that's for 5-minute data. Everyone in here, I'm sure, wants 1-minute data or sub 1-minute data, right? So do the math. You quickly end up with a lot of API calls to a lot of sparse APIs that you probably cannot rely on your customers calling and letting you know aren't working. This is also very important when you're rolling out software because we want to be able to roll back quickly. And we can't roll back quickly unless we have continuous testing in production that tells us when something is broken or has gone wrong. So let me show you another demo. I'll motivate this a little bit with an auto rollback demo. So I'm going to close up some of these. So for this demo, I'm going to use Code Deploy. Code Deploy is another AWS service focused on deploying software or any bits that you want out to EC2 or auto scaling. So in this one, I'm just going to do a quick auto rollback demo. One of the nice features of Code Deploy. Excuse me. So this is my CloudWatch application. I'm going to deploy to a set of EC2 instances that I've named auto rollback. I will pick a new version of my software. In this case, I'm going to deploy everything all at once in parallel. Don't do that. But for the purposes of a demo, to speed things along, I'll do that. And then as you see down here, I have it configured to automatically roll back. So one of the nice things about Code Deploy, I'll just kick this off, is when I'm doing a software deployment, I can register CloudWatch alarms to the Code Deploy application. And if any of those alarms go into alarm, if they trigger while the rollout is happening, Code Deploy will detect that and automatically stop the deployment. And if you want, you can also configure Code Deploy to automatically remediate it by rolling back to the last good version that was deployed. So in this case, I'm just kicking off a deployment here. I'll jump in here real quick. For those of you not familiar with Code Deploy, I'll just describe what you're looking at. Up here is a lot of static information about what I just requested. It's essentially the files that I'm deploying, where they're going to, the deployment ID. Down here is the instances that I'm deploying to. So in this case, I'm just deploying to 3 EC2 instances. This will periodically update, and you can watch progress as it rolls across the fleet. In addition to, so now that I've got Code Deploy up and running, I'll go over to CloudWatch. So for those of you, again, not familiar, this is CloudWatch. CloudWatch is our monitoring and alarming tool for AWS customers. This is just a very simple metric that I set up. It's measuring faults on this auto rollback demo fleet that I have. So in steady state, everything is looking good. There's no faults happening. We're nice and happy. Over here, there's an alarm associated with CloudWatch. Let me see if I refresh, if I can catch it. OK. So I just gave this graph a quick refresh, and you can see suddenly we have faults. So likely those faults are attributable to this deployment that's going on. Oh, so you can see that the deployment succeeded. It beat the graph. Well, that's what you get for doing live demos, right? Let's see. Yeah, so in this case, I probably should have made my deployment slower because my deployment finished before the alarm could actually trigger. So there you go. I guess that drives home my point that you need to monitor things continuously with high granularity. As you can see here in my previous demo of this, what I was hoping to have happen, of course, is that the alarm triggers and an automatic rollback gets kicked off. So this is the original deployment. It gets stopped. So as you can see here, it succeeded on the first host. The alarm went into alarm. It then failed the host that it had started mid-flight, and then it skipped the last host. Then that deployment stopped, and we triggered an automatic rollback, which returned the fleet back to its previous state. OK, so that's just a quick demo of automatic rollbacks. And a lot of that, of course, can't happen if you're not driving traffic to your APIs during a deployment, because you'll never have anything to alarm on. Cool. So testing is something that both are grizzled veteran and our newbie are very happy about. Now we're going to get into some more modern topics that are going to make our old guy grumpy. So let's talk about immutable infrastructure. So before I jump into immutable infrastructure, I'll start by talking about in-place deployments. So in-place deployments is probably the traditional way that most of you have deployed software in a data center or onto hosts that you typically own. I'll visually explain this. So what we have here is a very simple application fronted by an elastic load balancer and 2 virtual machines, 2 EC2 instances. To perform an in-place deployment that's not impactful, the first thing I'm going to do is I'm going to remove traffic from one of the instances I want to deploy to. So I'll stop sending customer requests to it. Then I will take the first version of the application and I'll turn it off. Once it's off, I'll install a new version of the application, so V2. Once V2 is up, I can test it as much as I want. I can validate that everything looks as healthy as I care to validate. Note that this is not causing customer impact because we're not routing traffic to this version 2 yet. It's still out of the load balancer from that perspective. Once we're confident in the change, we can reintroduce traffic to the load balancer, and our in-place update has happened, right? So this is the very traditional way of doing a software change. It's basically paving bits on top of a pre-existing virtual machine, replacing what you have with something new. Let's talk about, my generation would say, yep, that's how you do software change. The new generation would say, that's really old school, what the heck are you doing? So let's talk about immutable infrastructure. So immutable infrastructure is the religion, and Bluegreen is sort of an implementation. So philosophically speaking, immutable infrastructure is this idea that rather than mutate state, so rather than change an existing resource that we have out serving customer traffic, we instead introduce a new copy of it that's updated or configured the way we want, and then we migrate customers to that new thing, right? So we don't touch old, we don't mutate, we keep it immutable, and instead we move people to a new one. So in the context of updating software on an EC2 instance, what does this look like? Same exact example here. We have a load balancer, 2 instances that we want to update, and we have V1 running on one of them. This time we're going to spin up an entirely new virtual machine, so spin up another EC2 instance with the new version of software, so now we have version 2 up and running. Once that's done, we can introduce traffic to it, right? So tell the load balancer to start sending customers to the new version of the software, and then finally turn off the old version of software. Just like before, when we spin up that new virtual machine, we can test it as much as we want. It's not serving any customer traffic. It's in isolation. We can do whatever we want with it. So some of you might be thinking, well, it seems more complicated, like I had to spin up another virtual machine and get my code on that. Isn't it just easier to take the thing I already have and update it? Maybe. I think the place where this really shines is in rollback situations, right? So one of the nice things about a rollback when you're doing a Bluegreen deployment is this, right? So to do a rollback, I just reintroduce traffic to the version 1 virtual machine, which I've kept around for a little while. And I can be highly confident that when I start sending customers to that version of my application, it's going to work. I mean, nothing has changed about it. The only thing I did was stop sending customer traffic to it. And then, of course, I'm going to unbind version 2, and I'm right back to where I was. So that's a really nice thing. One of the, excuse me. So I would say with immutable infrastructure, the rollback story is something that you can be highly confident in. Unlike in-place deployments where the rollback really means you have to figure out how to undo the state change that you did on the virtual machine, and that can be very error prone. It also means if you really want to do it with high confidence, you need to, with all of your software changes, test the rollout and the rollback scenario together at the same time before you go to production. With this, much more simple, much more straightforward. I would also say the rollback is typically faster in a Bluegreen deployment because all we're doing is instructing the load balancers to start sending traffic to it again. In a rollback and an in-place model, we have to figure out how to, again, undo the changes and then reintroduce traffic. So a little bit more work. Let's do another demo. Or let's try and do another demo. OK, so what I'm going to demo for you now is using code deploy to do immutable Bluegreen deployments. This is new functionality, so this actually isn't even released yet, but I figured, why come all the way to Vegas and not show something new? If you're an existing code deploy customer and you want to play around with this, come find me after the talk. We can get you signed up for the beta, The feature is going to release sometime early next year. So what I have here is the typical congratulations page when you launch your first code deploy sample application. It's just a, it's a typical welcome to code deploy. So now let me do a Bluegreen deployment to this. So I'll select Bluegreen. So this is pretty much the exact same page I filled out before to create a deployment. The only difference you'll notice here is that my deployment type is now Bluegreen. Let me pick a version. Again, for the purposes of speed, I'll go all at once. I'm not going to bother with automatic rollback in this case. So let me kick off the deployment here. So same deployment visualization page we had before. You'll notice a few things have changed. So over here on the right-hand pane, we don't have a single slider bar, but we have it broken down into multiple sliders. So the steps that are going to happen with a Bluegreen deployment, step one is, of course, we're going to provision new instances. So we're going to make a copy of your autoscaling group or spin up new EC2 instances. That will be the green fleet, the new fleet that we're going to target. Then we'll perform the software change. So we'll actually just do a traditional code deploy deployment onto that new infrastructure. Once that infrastructure is deployed to, we will optionally wait. So at that point, we've stood up your new fleet. It's running, and it has software running on it. We then you can optionally pause the deployment. That gives you, as the deployer, an opportunity to test it, or you could even automate the testing at that point, right? So you can make sure that the green fleet is working as expected, run it through your functional and integration tests, send synthetic traffic to it, whatever you want to do to build confidence in it. Once you're confident in it, then you would perform the routing step. So in a moment here, once it's done provisioning and deploying, you'll see a little button pop up that'll allow us to route traffic. So when we route traffic, I didn't go through the setup of this, but essentially as part of defining my application, now I also include an elastic load balancer. So once code deploy knows about the load balancer, it will handle all the coordination of unbinding old instances and binding new instances. For those of you who are a little bit more familiar with code deploy, a lot of the existing configuration works. So in code deploy, you can set up your deployments to deploy in a phased fashion, right? So you can deploy one instance at a time, or 10% at a time, or 50% at a time. All of the same configuration still works with Bluegreen deployments. So when I actually perform that traffic swap, I can do it in a phased manner. I can swap 2 instances in, swap 2 out, see if I like that, and continue on in that fashion. Just scrolling down here, just since we have some time. What you can see here is just a view of our traffic. So right now, our original instances, there's 3 of them still in the load balancer. And because we haven't instructed code deploy to perform that swap action, none of our new green instances are in the load balancer. This is the same visualization page we had before. Here, I'll give it a refresh and see if I can catch things midway. So again, this is the same instance level view of the deployment that's happening. Now we have essentially 2 fleets. We have the replacement fleet and the original fleet. And we also include traffic status for those. So are they serving traffic or are they not? As this updates, you'll also see lifecycle events happening on the new fleet. And of course, the original fleet isn't being touched. It's just in the load balancer serving customers. Excuse me. Excuse me. So as you can see, provisioning is done. Now we're just waiting for the deployment to wrap up. I'll do the thing I tell my people not to do and spam refresh until it tells me what I want. So we're in after install, so we should see this wrap up here pretty quickly. Sorry, say it again.
You have a new app running, right?
Yes.
Is the step weapon in this way?
Yes.
That happens. Are you running an automation test against the new app?
Got it.
That's happening?
Yeah, so for everyone, so everyone can hear. The question was that step 3, when I go to flip the capacity, am I running any tests ahead of that, or are tests automatically kicked off? So for each of the hosts, this is concept in code deploy called lifecycle events. This is the hooks where you can run any code you want. We have we've introduced a couple new lifecycle events. So before we perform the flip is one of the new ones. So yes, you can use that to trigger any kind of testing you want on the green fleet before we perform the flip. Yeah. Okay. So let's see here. I'll probably cut it off at this one, but go ahead.
The YAML file, can you tell it how long you want it to wait before terminating the original instances?
Okay. The question was in the YAML file, so someone who's clearly used code deploy. Code deploy has this YAML file that is essentially telling code deploy what scripts you want it to run when it's deploying. The question was, in that YAML file, can I specify how long I want it to wait? That configuration actually lives on the deployment group. So per stack that you want to deploy to, you can individually configure each of those to tell us how long you want to wait, right? So you can tell us to wait, an hour, a day, 5 days. Or if you don't want to wait, you're using continuous deployment and you don't want a manual action in your automation, you can just tell us to start deploying immediately. All right, starting to think. Oh, there we go. So now the deployment's ready. Now, as I said, we've got the green fleet stood up. We've got the deployment done. Now I can click this route traffic button. And this will actually start the process of binding the new green fleet to the Elastic Load Balancer and unbinding the old fleet. Since I did this all in parallel, this should happen relatively quickly. I'll sit here and, again, spam refresh to see if I can catch our display in an interesting state. Sure, go ahead. I'm sorry, ask the question. The question was, would these 2 instances use the same database or a different database? That's going to be kind of up to you as the implementer. In this example, this is just, I'm thinking of this as a static web service, so they could both call the same backend. That would be fine. My first demo happens too fast. My second demo, too slow. Yeah, that's right. Go ahead. Sorry, ask it again. Yeah, so the question was, will these demos be available? Yeah, we could probably make them available. If you go to AWS Labs, there's a code deploy section, and we'll see if we can get it all in there. So you can check it out there. Okay, so now you see I managed to finally catch it in a intermediate state. So now we've bound the 3 green instances to the load balancer, and we have the original 3 instances still in place. The next step, of course, is that we're going to begin the unbinding process for those last instances. Oh, actually, so that's now completed. So now you can see all the old instances are gone, and now we've essentially completed the deployment. Last thing that happens is we can optionally terminate your old instances. Just like the wait step that I talked about in between switching, you can specify how long you want us to hold on to your old blue fleet before we terminate the instances for you. If you want us to not touch it and just leave it there indefinitely and you go and clean it up manually, that's also an option. Most people want to keep it around for some number of hours or days after deployment as a rollback mechanism. Okay, deployment's done. I'm going to soldier on here. All right, I have to start talking a little bit faster. Okay, immutable infrastructure. Inevitably when I talk about immutable infrastructure and we talk about Bluegreen deployments, the question is, when should I use them? Should I always do Bluegreen deployments? In general, my advice is prefer immutable infrastructure, prefer doing it if it at all works for you. There are a couple corner cases that I'll call out where immutable infrastructure can potentially not be the perfect fit. Do note that the deployment is slightly longer, as you saw. We have to spend time standing up virtual machines and then deploying to them. Clearly, deploying to existing virtual machines is going to be a little bit faster. That's an amortized cost, in my opinion. You know, you can spin up those virtual machines out of band and not really worry about that time. But if you're ultra concerned about how long from the time you hit the button to the time it goes into production, immutable infrastructure is going to take a little bit more time. If you're storing state on your EC2 instances, do note that the whole premise here is that we're going to throw those instances away, and any state that's sitting on those instances is going to go with them, right? So if you're storing, if you're caching data on the instances, or you're storing logs, or you're storing anything else, in a blue-green model, that's not going to stick around. You're going to have to figure out how to get it off. My general advice is to leverage other AWS web services, of course, right? So store data in stateful services like S3, Dynamo, if you're using caching, Elasticache, et cetera. Finally, when you perform a blue-green deployment, there is a period in which you are running more instances than your standard footprint, right? So we're going to spin up an extra copy of our fleet to be able to move to it. So if you are in any way resource constrained, which if you are using the cloud, you are probably not, but let's assume maybe your company bought just the right amount of reserved instances and won't let you spin up anything else, that's something you're going to have to go figure out and negotiate, ask for 3 more instances, instance hours a deployment. So other than that, I think I tend to agree with Riggs here. You'd be crazy not to do immutable deployments. Still, there are those that won't. Oh, this is my dev manager is always here to remind me of a couple anti-patterns to call out. This is one that I occasionally see with blue-green deployments. So people will stand up their green fleet in their test environment. They will test it in test, and then they will perform a swap, right? So they will actually kind of promote between their stacks, right? So they'll promote test to production, and then they'll move production back down to test. I'm not a big fan of this because it breaks the compartmentalization that we were talking about earlier. It means that wall between your test environment and your production environment is now semi-permeable because you have to have permissions that operate across the boundaries, or you have to do some complicated switching of permissions as you promote. So in general, I think if you're going to do a blue-green, avoid this pattern. Just spin up a new copy in production and move to it rather than trying to kind of swap between your stacks. Again, I agree, crazy. All right, let's talk about containers quickly. I've got a little bit of time. So containers, containers is another new technology that you'll encounter. When people ask me about how do containers relate to the software release process or the deployment process, I start by explaining, to me, containers are just another turtle on the stack, right? So they're another form of compartmentalization. They're another form of virtualization. Containers are, in and of themselves, I don't think they change the approaches that we will take to deploying software. They just add additional assurances, which are nice to have. So let's look at a blue-green deployment using containers. So here we have the blue fleet on the left, the green fleet on the right, and we'll visualize the containers as these little gray boxes. If you're using something like Docker, I typically think of it as a bounding box around my application, right? So I get nice assurances about what my application can access on the virtual machine, right? So processes, file systems, ports, et cetera. In a traditional blue-green model, I would just stop routing traffic to version 1 of this and start routing traffic to version 2. With containers, it's essentially the same. I need to move my customers from version 1 to version 2. The thing that's nice about containers is once we draw this bounding box around our application, if we're highly confident in that, there's really no reason why we can't run both versions of our application on a single virtual machine, right? So rather than spinning up a whole new virtual machine, putting containers on it, we can actually operate with a lot more confidence using containers in a multi-tenancy way, right? So I can actually run multiple versions of my application or multiple disparate applications on the same virtual machine and have a fair degree of confidence that that's going to work out. To me, this is really the principal advantage of containers as they relate to deployments. I don't have to use as many virtual machines. And I save the cost of spinning up a virtual machine when I'm doing a blue-green deployment. So regardless of how you deploy, containers are a good thing. I don't want to come across as thinking that they're not. As I said, they create a nice perimeter. They add consistency to your development process. So another really nice advantage of containers is If you develop within a container on your desktop and move that onto your production servers, you have a higher degree of confidence that that change is actually going to work in production the way it worked in your test environment, because you don't have a bunch of cruft or things that you can access on your dev desktop that you can't access in production. The container is kind of enforcing those best practices. Containers in general are a great packaging mechanism, right? So they make a nice little bundle that you can move around pretty easily. So these are all good reasons to prefer containers, but I don't think they fundamentally change the approaches you should take when you're deploying or managing your fleets. You should still compartmentalize, you should still adopt immutable infrastructure. One of the anti-patterns I see with containers, everyone hears about containers, they get excited about it, and they go back to their monolithic application and they containerize it. I'm going to use air quotes there. So they take this big application and they break it into a bunch of microservices. I'm going to use more air quotes, right? And they create this monstrosity, right? So they have a bunch of things running in containers that are highly coupled to each other and need to all be on the same virtual machine. This does not make for a better deployment process. You've taken what used to be deployable as a single unit, and now you've made it much more brittle. Now I have, in this case, 5 separate units that all have to be deployed in lockstep, and I have to know the relationships between the pieces in order to deploy them. So my advice is, like, it's fine to start containerizing your application as a first step, but don't view that as the end step. If you just create 10 little applications that all must be working together on the same box, you haven't probably solve your complexity problem. Instead, you want to move to a world like this, right? Where your containers really are operating independent of each other. You can run multiple copies of them on the same virtual machine, and you can create clusters that can then fail independently. Right now, when I want to update the green application in this case, it's very straightforward to do so. I don't also have to coordinate what the state is of the other containers that are running on my virtual machine. All right, we've made it to data. So the final showdown, data, right? So what do I do with stateful stuff when I deploy? How do I deal with it? So many a book has been written on how to manage data in an enterprise environment. Many master's thesis and dissertation has probably been written on this. I'm clearly not going to go into the level of depth this topic probably deserves, but I'll cover what I view as probably the most common case for a lot of customers that's pretty easy to get wrong. So in this example, I'm not going to talk about any particular data schema. I'm going to represent everything as shapes, just to keep things simple. So in this case, what I have is a database. The shape of my data is this beautiful green triangle. I have a web service here. So I publish, the web service is expecting to pull triangular shaped data out of my database. And then my web service has 2 clients, each of which are also expecting triangular shaped data. So what do I want to do? I want to move to a new schema, right? So I want to move to a new shape of data. I want to introduce yellow squares. The first thing I'm going to do is I'm going to update my service to be able to read and write and speak yellow squares. Once I do that, everything's simple. I just introduce squares from my database, and everything works just fine. It, of course, does not. What I always inevitably forget about is my clients, right? Which are much harder because they can be all over the place. My clients don't know how to speak squares because I haven't migrated them to speak squares. And so they immediately break, even though I did a ton of testing on my actual web service and everything worked fine, all my APIs worked as expected. It's when I get to dependencies that I have a problem. All right, so let's try again. You will see I've cleverly colored our clients blue, hint, hint. What I really think, the trick to me in managing data is you should really view it as a migration of your clients. I think the easiest way to think of it as another type of immutable change, right? So migrating your clients to a new data format as opposed to performing a software change in place. So same thing, I want to introduce squares. First thing I'm going to do is update my service or my request router to be able to read and write squares. I'm also going to make sure that it continues to read and write triangles, right? So if my clients are requesting our original data format, let them keep doing so. We don't have to update them yet. Once I have this in place, I can start publishing squares alongside triangles. Then I can introduce new clients. These new clients are my green clients. They know how to speak squares. Once I have actually seen them reading and writing the square data and they're happy with it, then I can start to drain away traffic. I can start to migrate away my clients that are speaking the old data format, and eventually I can turn them off. And in doing so, I've managed to migrate my customers to Square data without causing an impact. I think this is very similar in approach. Clearly, a lot of the complexity here is in that request routing layer. So having the request router be able to serve two disparate types of customers with the data that they want, you have to get that right. That's still, I believe, a lot easier to get right than a lockstep migration of the request router along with all of your clients. Break that apart and view them as separate steps. So what can you do to make this easier on yourselves? I'll do one more demo. It's more of a static demo, but. So for those of you who are familiar with application load balancers are a new load balancing solution that go along with classic load balancers, also formerly known as elastic load balancers. And they have a really cool feature, which is path-based routing. So with path-based routing, I can actually, with a single load balancer, specify multiple paths and have those paths route to different compute capacity, which is what I've done in this example. So here's the load balancer page. If I click on listeners over here, I'll show you I have two separate sets of listeners. So what all this is saying is that I have, for any path that is prefixed with v1, so if I am using RESTful services in this case, and I version my path in the URL, all of the traffic that is prefixed with version 1 will get routed to my sample app version 1. All traffic that is on version 2 will get routed to sample app version 2. And then I have these target groups. These target groups are backed by ECS. So ECS is the EC2 container service. So just like before, you'll see I have a very mirrored setup. I have a sample app version 1 and a sample app version 2. And I have 4 tasks running for each of them. So you could think of this as 4 copies of my application running on my cluster. Again, because I'm taking advantage of ECS and containers, I can run these copies of my application on the same virtual machines, or I can smear them across multiple virtual machines, however I want to do it. The nice thing here is that the load balancer now acts as that request router, so I don't actually have to get as much right. As long as I'm versioning my application or my APIs, my RESTful web services with a version number, the ELB will route to the appropriate application servers. And this is just a really dumb static web page, but as you can see here, it's the same load balancer that's running both the version 1 and version 2 of my application. The only difference here is the path. So I think this is kind of a neat trick. I definitely think if you're looking at load balancing solutions, definitely check out ALB, check out the path-based routing. I think you can make a lot of these migration scenarios really straightforward to do. All right. Am I back? Cool. All right. Despite a little slowness, I managed to finish with a little bit of time left. So just to quickly go through lessons learned again, if you want to reduce the blast radius of things, you need to introduce changes slowly, compartmentalize things, and break them up into pieces. If you want to be able to roll back, you really need to have continuous monitoring or continuous traffic being driven to the applications you want to be able to alarm on. Prefer blue-green deployments, prefer immutable infrastructure when you can. Containers are great. Use containers when you can, but I don't think that you have to fundamentally rethink the way you deploy your software by using containers. And if you're doing a data migration change, of course, view it as that, a migration, as opposed to just a standard software update. Cool. I think that's all I have. Thank you all for spending your last few